Hello, everybody. Hi, welcome to another segment of Pabalin Physics Classroom. Okay, today we'll be looking at 3.3 of your textbook pertaining to what we call your force and motions. Okay, now force and motion, the main idea that we are looking at, or the summary of the whole topic, revolves around Newton's law. Or how does forces and actions, how are they linked together? What are the different actions that are here when certain situations occur? Now, to understand this in detail, okay, we will first need to look at the effects of forces. Okay, when you apply a force, what does it cause? Okay, for example, when a force is applied onto a body, what are the possible actions? Okay, it can be applied on a stationary object, and what happens? It causes the stationary object to start moving. Where for moving objects, I can actually increase the speed, decrease the speed, or even change its directions. Okay, so when we talk about applying a force, I actually have an outcome. I actually change something. Okay, and that something is what we call the effects of forces of force. Okay, so when we say the object experience zero accelerations, okay, when object experience zero acceleration, you'll find that zero acceleration actually implies that the object can be stationary or is moving at a constant speed. Okay, now how can stationary, we all know that the thing is not moving, it's not having any speed. As a result, is not having any acceleration. This I think is quite easily understood. But what happens is when the object is moving, when the object is moving, but how the speed is moving, there's a speed, the object is moving from point A to point B, but how can there be no accelerations when we say the object is moving? Okay, partly because of the understanding of the word constant. Okay, when it has a constant velocity, it means that the initial speed or the initial velocity of the object is, let's say, 10 meters per second. The final speed after, let's say, maybe 2 minutes, okay, after 2 minutes, okay, the speed is still 10 meters per second. That's what I mean by constant velocity. The speed and the direction, everything remain the same. So as a result, what happened to the accelerations? Remember, acceleration talk about change in speed. And when we say V1 and V2 is still having the same speed, we are indirectly saying that there isn't any change. There is no change in the speed. And this is what I call zero acceleration. Okay, no change in speed, or what I call zero acceleration. If you look at it in terms of formula, okay, if you look at it in terms of formula, when I look at no change, when I look at constant speed, when I say V1 is 10 meters per second, V2 is 10 meters per second. In terms of mathematics, how do I prove that it is zero accelerations? Okay, we'll go back to the first basic principle of kinematics, whereby we look at the formula for acceleration is minus initial speed divided by time taken. Okay, in this case, okay, you'll find that the final speed I'm having is 10 meters per second. So the final speed I'm looking at is 10. Initial speed I'm looking at is also 10. Okay, so you'll find that the numerator for acceleration formula, final minus initial, the numerator will be a 10 minus 10. And as a result of that, you'll find that 10 minus 10, my final value in my numerator is actually a big fat 0. Okay, sorry, it's a big fat 0. And as a result, 0 divided by time, anytime I give you, the answer here will be 0 acceleration. Right, so in terms of math, in terms of quantitative analyzing, where you find that 0 acceleration does apply to stationary, and it also applies to actually object moving at constant speed. Okay, so 0 acceleration doesn't mean 100% the object could be not moving. It also could be that actually the object is moving, but it's actually moving at constant speed. And as a result, you'll find that if I relate this to the law of motion, Newton's law, okay, you'll find that Newton's law states that, okay, when resultant force on the object is 0, okay, or what we call F net of the object, net force acting on the object is 0, the system is actually what we call balanced. The forces on the object is balanced. And as a result, you'll find that with net force 0, okay, the acceleration of the object, if you look at the math, okay, F net being 0, equal to MA. Okay, if F net is 0, M times A must be equal to 0, mathematically speaking. Then, but we all know that the mass of an object cannot be 0, 1. Okay, everything has mass. So as a result, if mass cannot be 0, but yet the product of MA is 0, it will mean that acceleration is actually 0. Okay, so when we say Newton's first law, and when we say that the net force is balanced, we are actually indirectly saying that the acceleration of the object is actually 0. Okay, and that's what Newton's first law said. Okay, when the object is at rest, which is stationary, that what we mentioned in the previous slide, or he is moving at constant speed, okay, he will maintain this position. He will maintain this particular motion. Okay, be it just now at rest, so he will still be at rest later on. If he is moving just now, he will still continue to move at the same speed, unless a resultant force acts on the object. So if no resultant force acts on the object, he will always continue his last motion. Okay, if his last motion is stationary, he will be stationary now. If the previous motion is moving at a certain speed, the current motion will be still moving in the same speed, okay, when the net force is 0. That's what the idea of Newton's first law. Okay, the object will actually be picking up or continue his last motion. Okay, this is what is mentioned. Okay, when it's stationary, no horizontal force act on it. Okay, means resultant force is 0. Okay, so if the object is moving, okay, if the object is not moving, he will still not be moving. Okay, so no resultant force, no force acted, confirm no net force. Okay, because there isn't a force to begin with. So if no net force means acceleration is confirmed 0. So as a result, I will know that the object will remain in its last motion, which is stationary. Now, what happens is when the object is moving at constant speed. Okay, constant speed when there is a force. If there's a force acting on it, let's say horizontal force. Okay, so I have a force, let's say I will have this number is, so I will have this, let's say I have 10 Newton here. And at the same time, the friction is actually 10 Newton. Okay, so you'll find that when I have two forces acting on it, the driving force, okay, this is the driving force, this is the friction. Okay, so when I have 10 Newton and 10 Newton each, you'll find that when the force is equal, okay, the net force, if you take Newton's law, the net force on the object now is actually F minus small f. Okay, the applied force, the driving force minus the friction. Okay, so if they are the same, okay, you'll find that if big force, big F and small f is the same, if driving force is 10 Newton, friction is 10 Newton, this is 10 minus 10. Answer will be 0. So that's why I am able to deduce that the resultant force is 0. And as a result of 0 resultant force, I can also deduce that the acceleration of the object now is actually 0. Okay, but remember, when I say acceleration is 0, it implies it could have two purposes. It could be acceleration is 0 means the object could be stationary, or it could be traveling at constant speed. In this case, because the object is already moving, now because the acceleration is 0, he will still continue his last motion at the last state. Okay, which means he will still continue his last motion with his velocity at the last state, which is the last value, which is what we call traveling with constant speed. As for Newton's law, second law actually is another version of another condition, whereby now what happens is the resultant force is actually not 0. Okay, here I would like to refer to first law. Remember, first law state that the resultant force is 0. Okay, so first law, okay, F net is 0. Second law is F net not 0. Okay, so this is what we call two situations, whereby Newton's law, F equal ma, F net equal ma. First situation is whereby the F net is 0. Now the second situation is F net is not 0. Okay, so when the object is unbalanced, so which means it will be a resultant force, and as a result, it will mean that F net is not 0. F net is not 0. Okay, it can be a number 10, 20, 30, 40, all these numbers, which means that the acceleration of the object must exist. So which means the object upon subjected to a non-balanced resultant force, a non-zero resultant force, the object will actually accelerate. It will definitely accelerate. So for example, if I step on the accelerator, okay, so now if I step on the accelerator, the driving force now instead of 10, now let's say the driving force now become 40 Newton. Friction, which is between the floor and the tire, is still 10 Newton. Okay, so now if you apply Newton's second law, F net equal to ma first. Okay, Newton's law. Sorry, F net equal to ma, not 0. This case is not 0. Okay, so if I apply Newton's law, F net equal ma. Net force is actually Fd minus friction. That's the force acting on the object. We're on the car. So all the forces acting on the object will result in net force, or what I call resultant force. So if Fd equal to Fd minus friction equal to ma. So now what happens is if my driving force is 40 Newton, my friction is 10 Newton. You'll find that ma actually is a number. It's not 0. It's actually 30 Newton. So you'll find that m times a is not 0. It's a value, which means that m must be a value, a must be a value, which means that I can actually deduce that the acceleration is actually a number, or what I call there is actually accelerations. Subjected to the car is happening to the car. So as a result of acceleration, I will need to know the direction. So the direction is actually controlled by where? Controlled by the direction of the resultant force. So if the resultant force is to the right, okay, so the acceleration, he will accelerate to the right. Okay, that's where the resultant force direction is. So the air will accelerate following the direction of the resultant force. Okay, Newton's law says that. Okay, in general, this is what Newton's law F equal ma, or to be exact, what Newton's law mentioned. Remember, F first law and second law, the difference is F net is 0, followed by F net is not 0. So these are the two situations that we have for Newton's law. If you look at the math carefully, take note the mass of the object, which we always tend to forget, it has to be in kg. It has to be SI unit, followed by the acceleration of the jet, which always, most of the time, is always meter per second square. It's usually the mass that we must be careful. And the mass, sometimes the question does tend to give for small object, does give the mass of the object to be in grams. So the students, you will need to actually convert it to kg first yourself. Okay. For example, if it's friction, okay, let's say if you have a friction like I mentioned in the car situation below. So what happens is if your object now is, if your friction is actually higher, if the push is actually higher than the friction, okay, your object will actually experience a resultant force. Okay, so here is push, example, this could be 40 Newton, friction can be 10 Newton. So F net here will be 40 minus 10 equal to ma. So 40 minus 10 is 30. So ma equal to 30. So which means that ma is equal to 30, which means m is a number, a has to be a number. So aka, or what we call, there will be a friction. There will definitely be an experience. The box will definitely experience n accelerations. And the direction of acceleration, usually in the direction of the resultant force. In this case, if it's 40 Newton is to the right, 10 Newton is to the left. The resultant force I'm looking at, it will be 30 Newton. So I will know that 30 Newton is where? To the right. So I will also know the object will actually accelerate to the right side. Okay, when it's subjected to a net force of 30 Newton. Now, what happens is when I actually cancel, or when I actually remove the applied force, so now I only have friction. Okay, so it will be same thing, F net equal ma. Same as before, is still F drive minus friction equal ma. So now what happens is my F driving force is 0. So negative m equal ma. So you'll find that the net force now is actually negative. Okay, which implies it is in another direction. So if it's negative, mass has to be positive. It will mean that the acceleration has to be negative. Okay, because the product of M and A give the resultant force, which is the negative F. Negative in this sense, what does negative means? Okay, when we talk about vector and scalar, the negative plus and minus actually relates to where? It actually relates to the direction. So the negative sign here, the negative here, we actually talk about is direction. So instead of going to the right, which we assume just now, now the object actually experiences a resultant force going to the left. Okay, which is what we call slowing down. So when the object actually experiences a resultant force to the left, you will find that the acceleration will also be to the left, or what we call the acceleration is negative. And because the acceleration is negative, it will mean that the object actually will start to slow down first. So because originally he was moving to the right very fast. So what happened is the object will slow down first. Here, while it's moving to the right, it will slow down, and then it will actually accelerate to the left. Okay, if the force friction is still there. Okay, if not, okay, it will actually stop there for a while. Okay, so when you talk about Newton's law, the important thing about Newton's law is actually look at the Newton's law, okay, F equal ma, and actually work out the situation to work out what are the forces available, what are the forces subjected, what is the forces subjected onto the object. Then after that, look at what is the resultant force acting on the object, and from there you move on to see whether does the question need you to find acceleration or deceleration. Okay, remember F net is 0 is first law, F net is not 0 is second law. So it depends on which situation you are in. So for example, the object given is the object is 1000 kg. On the smooth floor, it has an engine force of 5000 Newton. Okay, so you have a car. Okay, so if the object is engine force is 5000 Newton. Okay, smooth floor means what? Smooth floor means the friction is minimum. Okay, negligible. Okay, so actually now is a good time to actually look at what is happening. Okay, at the keywords when every time you see the questions, highlight the keywords to see what is happening. What information is given to you. So whenever I say F is smooth floor, it means friction is minimum. When I look at engine force, okay, it will mean that whenever engine force, it will mean that there is actually a driving force, FD. Constant velocity, here must be careful. Constant velocity, okay, implies where the first obvious one is constant velocity implies zero acceleration. Okay, so these are the clues that happens in the question. Is it useful or not? Depends on what the question is asking. But these are the possible keywords that happens in the question, and the kids must be aware of them. Okay, so what is the resultant force acting on the object? Resultant force is F net equal ma. So F net can be broken down into different force in different direction. Okay, but in this case, actually, we don't need to look at what is the forces at different direction, because the question asks specifically for one thing. The question asks for F net, resultant force. When we say resultant force, okay, resultant force acting on object, resultant force means F net. So either one way I can find the individual component, or I can actually look at the right side of the equation, because I know F net is equal to MA. So if I can't find the individual components or the map scale, or quite maybe you need some touch, so I cannot find anything. Okay, so what we do now is this. So when you look at the questions now, okay, so you can't find anything from the individual forces. What is the driving force? All these things. So don't freak out. So what do you do is remember the equation has both sides, the left side and the right side. So if you can't find the individual forces acting on the object, but yet you still want net force, so which means you actually need this. You actually need M and A. Because if you have M and A, you multiply them together, you actually can find your net force. M given 1000 kg, acceleration you given already, constant speed means 0. So what is the resultant force acting on the object? Okay, it's actually 0. Okay, because based on the question, constant speed zero acceleration, and zero acceleration implies F net equal ma, means F net equal to 0. Okay, so take note of the calculations here. Now, for question wise, right, for this particular topic, question chapter 3 forces, one of the common keywords we use in your explanations, okay, explanation, okay, is this. Okay, we tend to use this word very often in our explanation, is the word resultant force. Okay, and of course, sometimes we also use words like resultant force or net force interchangeable, but remember that that's the keywords. Okay. Then same thing for another question. If we look at the question, say when I have forces acting on the object, 1000, the mass is 1000 kg, it changes from rest. Rest means speed is 0 meter per second. What is the resultant force acting on the car when the car is moving on the smooth roads? Okay, so the acceleration, if you look at the question, you can find the formula. You can find based on the formula is change in velocity, which is final minus initial. Okay, initial is based on the question is at rest, which is 0 already. So if you put in the number in, substitute the number in, you'll find that the acceleration of the object is actually 4 meters per second square. And based on Newton's law, F net is ma. Okay, and you have m times a, which is 4000 Newton. So F net force acting on the object is actually 4000 Newton. Okay. Now, so in summary, okay, you see this summary notes in page 55 I got from there. Okay, it's a good summary. Okay, when we talk about Newton's first law and second law, okay, Newton's law is actually what you see, F net equal ma. Okay, but under ma, you'll find that, okay, there are two different situations. One is whereby the object, the force is balanced. Balance means F net is 0. So what does it mean? It could mean the object is at rest. Why? Because a is 0. Or it could mean the object is traveling at constant speed. The other situation is whereby we have second law, whereby we say the F net is not 0. Okay, so F net not 0, it means that there is definitely acceleration. Okay, so when there's definitely acceleration, two things can happen. It's either I have the object start moving, or the object actually start to change its motion. Motion can be speeding up, change direction, or even slow down. So it depends on the question itself. So Newton's law in short, okay, it can be summarized into these two like small mind map here. Okay, so students, if you are not sure about Newton's law, how to apply the simple application of Newton's law, you can rewind, stop the video, and then rewind back like maybe 5 to 6 minutes ago. Then after rewatch the video to get the understanding of what actually is Newton's first law and second law. Okay, because that's the good thing about like online learning. Okay, you can actually pause the video and repeat and try to look at the video again and again, okay, at your own time and your own pace. Okay. Then after that, we have Newton's third law. Okay, Newton's third law is it's more like a supplementary law, whereby it talks about every action there is an opposite and equal reaction. Okay, so which means every forces that we see, it actually occur in pair. Okay, there's an action and reaction, and the common thing about action and reaction pair is that the forces are actually equal in magnitude, okay, and they are opposite in directions. Okay, and of course, the last but not least, they act on different body. Okay, they coexist differently at different body. For example, the object weight and force is at the same magnitude. Okay, weight is going downwards, the object is going downwards. Okay, but you'll find that, okay, although they are like the same, okay, you'll find that how does F and W come about? Okay, is F and W come about where? When the object is resting on the table. Okay, so when the object is resting on the table, okay, it exerts a force on the table, okay, due to its weight. And as a result, the table will exert a force onto the object, and the object will experience this force as F, or what we call reaction force. Okay, then as on the other case, okay, if you look at the weights, where does weight come from? Okay, weight actually comes from where? The weight of the object actually comes from the gravity pull of the Earth. So in short, if you look at Newton's law, you'll find that gravitational force of Earth on the box, aka the weights, is actually arise from the Earth pulling the box itself. So indirectly, I'm saying that when the earth is pulling the box down towards him, keeping the box down onto the earth, or what we call sometimes we say gravity pull. So when the earth is actually pulling the object down, indirectly, I'm also saying that the force, okay, the box is also pulling the object, the earth upwards. Okay, so this is what we call action pair, action and reaction pair. When the earth is pulling the box down, the box is also pulling the earth up at the same time. Okay, so this is what we mean by Newton's action and reaction pair. So you'll find that these two forces, they are opposite in direction, they're equal in magnitude, and they occur at different body. Okay, so this is what we see by Newton's third law. Okay, so in short, okay, this is the three laws that we have: first law, second law, and lastly, Newton's third law. In your in O level, Newton's third law is still not, I would say it's there, it's in syllabus, but it's still not as hot. It's not a hot topic as first law and second law. Because partly I would believe that because at O level, the kids are still quite not familiar with Newton's first law and second law yet. So they are really not really like, they won't go to third law quite in depth. So if you are still blurred or confused about third law, okay, you can pause the video and rewind back like 6 to 7 minutes ago and look at third law again. If not, you can look for your teachers, okay, or look for me, okay, or leave a comment at the comment bar below to see what are the areas about third law you're not sure and you want me to actually re-go through or highlight again. Okay, so if not, okay, Newton's first law and second law and third law. Okay, these are the three laws that it's actually what we call in dynamics, the three main law. Okay, so if you are not sure, okay, I repeat again, okay, you can look for your teachers or you can actually rewind back the video to see where you are unclear and take a look at it. And thirdly, if you don't mind, okay, you can actually leave your questions in below in the comment bar, and after that I'll get back to you ASAP. Okay, if not, thank you very much. Okay, have a nice day, everybody. Bye bye.